Good morning, guys. Welcome back to College Algebra. So we're gonna get closer toward the end of the semester. So we're gonna have our test number 3 really soon, maybe in 2 weeks. Today we talk about a new concept, solving exponential equation. But before doing that, let's take a look at our schedule. Okay. Let's see where we've been at. All right, so this is our syllabus. So we are right over here. Week 13, showing exponential equation. So you see, I'm using the whole week for one topic. I mean, this hard. Okay. I give you more extension for the assignment 3. So instead of submit it on, okay, when's the date for submission? April 18. You can turn it in assignment 3 on the test day. So you see the test day, the due date is April 25th. So you can turn assignment number 3 on April 25th. Okay. But if you want to turn it in early, I don't mind. Just go ahead and turn it in. Okay. But you can turn it in on April 25th. All right. So today we're going to just talk about showing exponential equation.
Did you say April 25th?
Yeah, April 25th, 25. Yeah, right here.
Okay.
Okay. So it's on the day we have test 3. Okay. Then you see that after we have test number 3, we have our final. You know, so after test number 3, we don't have anything else to learn. So we're gonna have fun. Actually, we have 1 week. We still have 1 week left. You see that it's nothing. So I just give you a whole week for rest. You know, to kind of review and stuff. You know, take advantage of this week though, because it's good if you have a few days to review everything, because the final is cumulative, so it covers everything. So it's good to review everything and prepare for the final. Okay, so again, assignment number 3 will be due on April 25th. Okay. Any question for me? All right, so I hope that you guys already watched the video. Let's take a look at the module. Someone keep coming, so excuse me, guys. Let's take a look at the module. Let's see. Let's see what video you're supposed to watch. Actually, you're supposed to watch before coming here, but I know that some of you did not. So, I mean, just make sure that you watch it after. So week 13, show an exponential equation. Let me move this. Okay. So all the way down here. Okay, so all the log property and exponential property, you're supposed to memorize that. Okay. Okay, so we are right over here, April 5th to April 11th, lecture video. You see that? Showing exponential equation. So you're supposed to watch this lecture. You don't have to read this. The PDF, if you have time, you can read the PDF, but I always recommend to watch the video first. And then next week we solve log equation. So the whole week of it, this week we spend it on solving exponential equation. I don't know if I should give you more example on Thursday or not, or maybe you guys, if we doing enough example today, then on Thursday you may have a day off. But I'm thinking about that. If you guys have any questions, just let me know, or you want me to give you guys more explanation on solving exponential equation, just let me know. Okay, so but you're supposed to watch this video. So let me click on this video. Okay, so you see that I'm just standing there and give you the whole lecture on exponential equation. Very, it's like a live stream class. So I mean, you better watch it. This is good video. Okay, I give you a bunch of different examples. Today I'm doing the same thing too. Okay. All right. Any question from me? Any concern on homework? So all right. Just a
Actually, I have a few questions about homework.
Okay, so what is the question again? I'm sorry. Any questions so far for me? Any concern on homework before we starting out solving exponential equation? All right, so let's just
I'm
go
trying to
ahead.
find a problem. Give me a second, please.
Oh, okay, go ahead. So remember, okay, assignment 3 due April 25th, not April 18th. I just give you guys more time. All right, I'm waiting.
Okay, so the first one is number 12 on the recent homework. It's e to the power of natural log parentheses 4, I believe.
Can you share the screen?
Okay, 1 second. I have to log into my open now.
Yeah, it's easier for me. So I hope that some of you already start assignment 3, right? I mean, you should start on part B of assignment 3. Okay. Then after today, you can start on part A, because which you can start on exponential equation, not the log one. But you remember that the exponential function and log function is kind of related to each other. They are inverse of each other, and because they are inverse of each other, sometimes we have to use the log principle to solve exponential equation. That concept I'm going to give you example today, very soon.
I already submitted my assignment, so I don't think I can access it.
Oh, you already submitted assignment?
Yeah, I forgot that.
You can well, if you want more time, you can keep working on that, and you can allow you to submit it later.
I had a decent score. It was just that one question I was curious about.
Okay, then that's fine. I mean that you on track. You're not falling behind. So that's good. Or you even ahead of time. So that's good. But anyway, you go ahead and share your screen so that I can have you really quick. Any other student have question for me on homework? because it looked like every time I come here, there's only one student asking me. There's only Luke's asking me. So I don't know. I don't know if you guys, the rest of you guys, okay on homework or everything is fine, or any concept you guys don't understand, you want me to go through again. Just let me know, okay?
Okay,
Yes, go ahead.
I clicked practice, so it's similar, but it's not the same question. But I'll share my screen.
Okay, go ahead. Let me see. You have to share the screen. Let me see. I allow you to do that or not. Hold on. I think I have to. Here you go. Wonderful.
Oh, I stopped it. My bad.
Oh.
Okay, it's starting right now. Okay, so do you see it?
So okay, let me write them down. Okay, let me get a piece of paper. Sorry. So EL and 3. All right, that's it. All right, anything else?
Let me see. 1 second. Yeah, something like that too.
Okay, so it's LN. Is that the fourth root?
Yes.
Fourth root of E. That's it.
Yeah, that's about it.
All right, just stop the sentence. Okay, let me share my screen. Excuse me. Okay. All right, so 2 problem here, and look, wanna ask. So the first problem you have, or someone the background noise, please. I think it's you, Luke.
My bad.
Okay. So the first problem you see that this related to a natural log. You see this LN over here is this natural log, and the second one is also natural log. So in order to simplify this, you just use one of the property I'm giving you. I gave you last time. What property? This one. Log base b. Oh, b raised to log base b of x equal x. So b raised to log base b of x equal x. You see the exponent here, the whole log is considered as the exponent. Okay, the b over here is the base of the power number. Oh, someone's coming. So you see the b and the b here the same. Then all you have for answer is the x itself. So now let's go back to this. The natural log basically, natural log ln is the same as log base e. You see that? E and e is the same. So this is turned out to be 3. Because ln is log base e. Okay, but they never written like this. They never written log sub e. No, it's not professional writing like this. They writing ln, but you know ln means log base e, and because the e over here, so that's why it cancel out. That's what you have left. It's just the argument, which is your number 3. All right. How about this one? Same thing. This is log base e. But before doing that, I need to play a little bit. Excuse me. This one I can convert it to, this is radical number. I can convert it to rational exponent. So I can write it as e raised to 1/4. Okay. And now I can apply the property. I can bring the exponent to the front, so it becomes 1/4 log base e. And log base e, natural log of e, is equal 1. Remember the formula? Log base b of b equal 1. Okay, this is natural log base e of e equal 1, which is the same as ln e equal. Okay, so 1/4 times 1 equal 1. And that's it. Got it? So in order to master this type of question, you just need to memorize all the property. If you don't memorize the property, you can't do it. Can't they give you the property? They already invented the property for you guys. Okay, well, this you have a calculator like this, but you're not allowed to use this. So you're not allowed to use this, so this is useless. So you have to memorize the property. Usually it's about like how many? I think 7 or 10. I think more than that. You know. Okay. So you have to memorize the property. Okay, this is one of the property we use. Another property right here. Okay, and the one right here, when I drop down the exponent, this is the property. Log b of x to the n is equal to n log b of x. Okay, this is the third property. Okay. It's not hard, but you have to write carefully also. You see that when I write the argument, when I'm writing the base for the log, I move all the way down. You see the base b here, I draw this as a subscript, and I write all the way down. It's not on the same level with log. The argument is on the same level with log, which is the x here. It's on the same level with log, but the b value here is not on the same level. It's subscript. Okay, so you have to write carefully. You have to write carefully. When you do assignment, you have to write carefully. Otherwise, you get your old careless mistake. Okay. Anything else? Okay, I'm sorry, guys. Recently, I have very bad allergy. Okay, so that's it. Now, today, as I say, we start our new section, new chapter. We learn how to solve exponential equation. Okay, so let me do a quick summary on the concept. There are two methods to solve exponential equation. If you watch my video, I mentioned that. The first method to solve exponential equation is using equivalence property. Okay. What is equivalence property? Okay. Equivalence property state that hold on, let me see. Equivalence property state that if you have two power number like this, two exponential expression equal to each other and have the same base, for example, like b to the x equal to b to the y. You see the base is the same. Then it implies x equal y. This is equivalence property. Okay. The second way, the second method of showing exponential equation is use. So first of all, use. Second one, use log principle. Log principle, we talked about that last week. Anyone remember what it looked like? What is log principle? What is log principle? Anyone? Okay. It's very important. Okay. You don't know the log principle, then you cannot solve exponential equation. So you must know it. There's a bunch of things you have to memorize. The log principle state that if you have log base b of x equal y, then this is equivalent to x equal b to the y. Oh my God, this is so important. Okay. Log base b of x equal y is equivalent to x equal b to the y power. We're going to use these two methods to solve exponential equation. Okay, let's jump to the first example. Jump to the first example. See, I have here. Jump to the first one. Example 1. This. Okay. On example 1, I have something like this. I have some things so that you can apply equivalence property. Okay, something's kind of very simple. How about this? Let's see. So exponential equation. What if I have 2 raised to the negative 3y plus 1 equals 60? So if you look at the equation, you recognize right away this is exponential equation because you see the exponent right here. Okay, the variable y is on the exponent. It's the part of the exponent. But if you look at on both sides of the equation, you look on the both side equation, the left-hand side, the base is 2. The right-hand side, the base is 16. Now, so we had a problem. The problem is that the base is not the same. 2 and 16 is not the same. And because it's not the same, we cannot apply the equivalence property yet. Because you see that in order to apply the equivalence property, both sides must be the same in terms of the base. Okay. So it means what? It means that over here on the right hand side of our equation here, we have to do something. I don't know what we're gonna do. You gotta do something so that both sides has the same base. Okay. Over here, the base over here is 2. So just think about that. If I can rewrite 16 as a power number with base 2, then both sides will be the same, right? So let me rewrite the left-hand side. The left-hand side, we're not touching that. Now, anyone can help me rewrite 16 as a power number with base 2?
Would it be 2 to the 4th power?
2 to the 4th power. Is that 2 to the 4th? Very good. It is 2 to the 4th power. Because 2 times 2 times 2 times 2 give you 16. Okay. Oh, now we see what? We see the base is the same already. See that? 2 and 2 the same. And because the base is the same, we can apply. Now I'm going to put it here. Now we can apply equivalence property because they are the same. If it's not the same, you cannot apply. Okay. Then the equivalence property said that if the base is the same, we can set up the exponent equal each other. Then -3y plus 1, which is the exponent on the left-hand side, equal 4, which is the exponent on the right-hand side. Everyone's following me?
Yes.
Yes. Okay. Good. Good. I'm going very slowly, so that people can follow. Just stop me if you don't get it. And now you see what? Now
Wait, why you?
Go ahead.
Why do you get equal 4?
Because the exponent.
Never mind.
Yeah, exponent equal. As long as you have the same base. Okay. So now we have a very simple equation. Everybody know how to solve this. Subtract both sides by 1. Divide both sides by -3. So your answer is y equal -1. Subtract both sides by 1. Divide both sides by -3. Then your answer is -1. All right. So make sure you have to go back and plug them in to make sure that your answer is not extraneous. All right. Let's go back, plug it in. -1 over here. Well, actually, on the test, you don't have to check it. You can check it on the scratch paper. You don't have to write it everything in. Oh, especially our test is not writing test, so this is good. But you still have to do something, right? You have to do on the scratch paper. So -1, you plug in here. -1 times -3 give you 4. All right. Oh, give you 3. I'm sorry. -1 times -2 give you 3. 3 plus 1 give you 4. 2 to the 4th give you 16. So look like our answer is correct. It's good. Okay. Any question on this exam? All right. Exam 2. All right. Let's do something a little bit more fun, harder a little. Something you have to deal with fraction. I know you guys had fraction, but you're gonna see fraction many times. How about like this? 11 raised to 3x plus 1. You see that when I'm writing the exponent, I always write really small compared to the base, equal to fraction 1/11 raised to x minus 5. Okay. Again, we know that this is exponential equation. We know the base on the left-hand side is 11. But the problem, the base on the right-hand side is not 11. The base on the right-hand side right now is 1/11. So that's the problem right there. That's the problem. We need to solve it first before we can apply the equivalence property. Okay. So you gotta ask yourself, how are we gonna convert 1/11 to 11? That's a question. How we going to convert 1/11 to 11? I'm sorry, I don't care about grammar over here. Okay, I'm just going fast. So that's the question you need to ask yourself. As long as you can answer that question, then look like that you already finished 50% of the problem of the question. All right, how? Answer. Excuse me. Okay. How are we gonna bring 1/11 to 11? Oh, that's kind of crazy, right? You can ask yourself, how come you can bring 1/11 to 11? 1/11 is not even the same as 11. 1/11 is like you take if you do division, 1 divided by 11 is to give you a whole different number. It's not the same as 11, but we can. All right, we're gonna use this. Use one of the formula we already learned. X 1/x to the n is equal to x to the negative n. Okay, so we're going to use this formula. This formula you already learned in intermediate algebra. Actually, you see that's during the time you're doing homework, maybe some of you just come across this formula. Okay, so just think about it. Right now we have 1/11, and the exponent for 11 is 1 right here. It's invisible 1. So 1/11 is the same as 1/11 raised to the first power, right? It's raised to the first power. Then if I apply the property, if I apply this formula, then it becomes 11 raised to negative 1. Everybody can see that. Good. So right now what do we have? We can write 1/11 as 11 to the negative first power. So my answer, my question right now become 11 3x plus 1 equal 11 raised to the negative first power, everything raised to x minus 5. Everybody can see that. Everyone's following me.
Is that plus or minus 5?
Minus 5.
Okay, gotcha.
Yeah. Okay. All right. It look like that we almost got it. Because right now you see on the left hand side we have 11. On the right hand side we also have 11. It looks like that we can apply the equivalence property. However, on the right hand side is not 11. This is 11 raised to the first power. It's a little bit different. Okay. So our next step, you're gonna bring 11 raised to the first power to 11 only. All right. On the left hand side here, I'm gonna touch anything. I'll just leave it for the time being. Okay. You're gonna apply this formula. X to the m raised to the n is x to the m times n. Everybody know this, right? I'll just say yes. Now you see that m is -1, n is x minus 5. I can write 11 raised to -1 times x minus 5. Everyone is following me. Okay. Stop me right away if you don't get it, okay? Stop me right away. So right now what we have 11 on the left. We have 11 on the right. It means we have the same base. Then we can apply equivalence property. Then we can apply equivalence property. Then equivalence property will give us 3x plus 1 equal -1 times x minus 1. And now we have a very simple equation. Okay, we can solve it. Distributed property. Add in both sides by x. Subtract both sides by 1. Divide both sides by 4. Your answer, x equal 1. Okay. All right. So I'm not going back and check. It's your job. Okay. You gotta plug them back and check if this is extraneous solution or not. So I'm not wasting time doing that. Just your job doing it. Okay. Just go back and plug them back in and check if it satisfies the equation or not. Most of the time it is. Most of the time it does. Okay, but you always have to check. You always have to check. For every time you solve any equation, you gotta plug them back and check if your answer satisfies the original equation or not. Okay. Any question on example 2? Example 3. Okay. Let's see. Again, we're gonna do the same thing. So today I'm just focused on the first method, equivalence property. Maybe I can jump to the law principle right now. Then on Thursday we can give you more example, because you need to know exactly what it looks like so that you can start with your assignment. Okay, so on number 3, I give you a problem. I give you the question that you have to use the law principle. You cannot use the equivalence property. Okay, something like this. Something like this. Again, 11 raised to the 1 minus ax equal to 9 raised to the 2x plus 3. So you look at the problem, you see that on the left hand side we have negative, we have the base 11. On the right hand side we have base 9. We have different base. Okay, I already say in the first example I said as you have a different base, you got to do something so that you can convert it to the same base, then you can apply the equivalent property. Okay, but when you look at this problem, you see the base 11 and base is 9. And you start thinking, how I'm going to bring 11 to 9 or 9 to 11? Is there any way we can convert? Is there any way we can convert 11 to 9 or 9 to 11 by using some exponential property we learned before? Is that a way of doing that or not? That would be very hard. 11 to 9. Okay. There's no way we can bring 11 to 9. There's no way we can convert 9 to 11 either. It means what? It means the first method, equivalence property, is not the option. It's not the option. It's not a method you're going to use to solve this equation, because you cannot bring it to the same base. Okay, and because and as soon as you know the equivalent property is not the option to solve this equation, you have to jump to the second method, which is we have to use the log principle. Okay, you have to use the log principle. So how I'm going to use the log principle? You're going to take log both sides. You can you can either take log base 11. So take log base 11 or log base 9. Either way. Either ways work. Okay, either ways work. Okay. Let's take log base 11. Let's take log base 11, both sides. Okay. Choose. Okay, I'm gonna put choose to take log base 11 or log base 9. So over here, I'll take log base 11. Okay. So I'm going to take log base 11 both sides. Okay. So my equation become log base 11 of 11 raised to the 1 minus 8x equal log base 11 both sides of 9 raised to 2x plus 1. Okay. Now the whole thing here, 1 minus ax, is the exponent. I can bring it to the front based on the property I gave you last time. So I can write 1 minus ax times log base 11 of 11. Okay. Equal same thing here. I bring 2x plus 3 of log base 11 9. Everyone's following me here. Bring the exponent to the front. Bring the exponent to the front. All right. Log base 11 of 11 give you
1.
1. So 1 times this is itself. So 1 minus ax equal 2x plus 3 log base 11 9. Okay. So your goal right now is to find x. Okay. And remember, I said it many times. Every time you see the parentheses, just go ahead and distribute it. So 1 minus ax equal 2x times log base 11 9 plus 3 log base 11 9. Okay. And now you see that there's 4 terms. 1 ax, this and this. So I'm gonna combine all the term with x together and the term without x together. So I'm gonna subtract both sides by 3 log base 11 9. So I'm gonna have 1 minus 3 log base 11 9. I subtract both sides, and I'm gonna add both sides by ax. So I have 2x log base 11 9 plus ax. Okay, everybody is following me that step. I subtract both sides by 3 log base 11 9, and I'm adding both sides by 8x. Okay, I'm adding both sides by ax here, and cancel them out. But I'm not writing like that. Okay, I just say it, but you know that when I say adding both sides, I mean that okay, you're gonna put 8x here and ax here, and you cross them out back in the day when you in high school, you know, but we are not anymore. All right, we're almost there. Almost there. So on the left hand side here is a number. You can use calculator. You're gonna put log base 11 times 11 of 9 to calculator, but you know you're not allowed to use it, right? So you just keep it. On the right hand side, you need to get the x by itself. You see over here, we have an x, and over here we also have x. So I'm gonna factor the x out. So I factor the x out. You have left is 2 log 11 9 plus 8. Okay, everyone's following me. That's it. The factoring step right here. G-shape, man. G-shape. You see something in common, you take them out and open parentheses, blah, blah, blah. Okay. And now, in order to get x, you just divide both sides by the left-hand side. Oh, divide both sides by this. I'm sorry, not by the left-hand side. So you divide both sides by 2 log 11 9 plus 8. So your answer will be 1 minus 3 log 11 9 over 2 log 11 9 plus 8. You divide both sides by the parentheses. You guys still following me? You guys still following me?
Just a lot of steps.
That's a lot of stuff, I know. That's why I spent a whole week for this. You know, by the time we get closer to the end of the semester, the concept is hard. The concept is hard. Okay. I mean, well, what if on the test they ask you to solve this? I don't know what the test look like right now. I haven't checked it yet. But if they ask you to solve this, then, you know, even though they just ask you to put the final answer, but you see that you have to go through a bunch of steps. Okay. All right. The question is, have we finished? Are we done? Or we have to keep going? Because we look like we got an X already, right? Look like we look like X done. Look like we already solved that. So we're gonna keep our answer like that. Oh, we have to do something else. You can remember on the test, you remember they just asked you to put the final answer. I mean, 1 minus 3 log 11 9 and over 2 log 11 9 plus 8. You can put everything into a calculator. And if you can put everything into a calculator, it's going to calculate it for you and it turns out to be the number. And I'm sure that that number is decimal number. So it's not a good idea writing decimal number as the final answer. It means what? It means this is our solution. Okay. And anyone asked me to go to plug them back into the original and check that? No, I'm not gonna do that. I cannot plug. I mean, this is, come on, it's too big. So I mean, it's a waste of time checking this problem. No, I'm not gonna put the whole thing in and start checking it if it turned out to be equal both sides. Hell no, I'm not doing that. I'm not doing that. So it means what? It means that don't ever get careless mistake during the process. Because if you get one careless mistake during the process here, everything wrong. And you cannot go back and check because the answer look like this. The answer is very complicated. Okay. Okay. So when you do the step, make sure you do carefully. You have to do carefully because you don't have time to go back and check. And well, even though that I will say that you should check because for every Chauvin equation, you have to go back and check. But come on, man, this is, I'm not gonna waste my 10 minutes to go back and check this. I don't have enough time on a test, right? I'm not gonna check this. If I got them right, I got them right. If I've got them wrong, everything wrong. I'm not wasting time back and check this. Waste of my time and waste of your time. So make sure that when you're doing this, you got it right, I mean you got them right. Don't get careless mistake during the process. Okay, you have to trust yourself. You must have your self-confidence. You have to believe in yourself. You got them right. All right, done. That's it. I'm gonna leave it like that. And you do the same for my assignment. Okay, I mean, assignment is no time limited, so you can go back and check, but still don't recommend it. Well, unless you have a very simple answer that you can go back and check. All right, so if you look at the example, it look like the example number 3 right now, it look like we haven't used log principle yet, right? Not yet, not yet. So this example is another type of question. You don't use either of the method we provide. You don't use either method I provided you. No. Now, let's take a look at example 4. In the example 4 is the one we're going to use log principle. Something like this. Let's see. How about let's see, something something you don't want to take the log both sides because taking the log both sides is one of the other option. Let me see something else. Because I don't want you to do, I want you to apply the log principle. Looks like I don't have any example here. Let me see, I can make it up. How about something like this? How about I don't know. Let me think a little bit. Let's see, because I don't have the example here, so I have to make it up. Something you have to use log principle. Okay. So the following equation. That's interesting. It's, probably the law principle is not, that's what it means right here. When we apply the log both sides. Yeah, but whenever we apply the log both sides, we didn't even use. How about like this? Let's see, we can apply the log principle now. 7 to the x power equal 60. Yes, we can do this or not. Okay. You see that when the block principle here, it go both ways. This is equivalence, is equivalent sign. It's equivalent sign, right? It means what? It means that I can write the left to the right, or I can rewrite the right to the left hand side. All right. Just imagine that this is your right hand side of the law principle. Okay. Then I can rewrite it as, sorry, let me move up. Imagine this is your right hand side of the law principle. Okay. Then I can rewrite it. I can rewrite the equation. So this is the law principle right here. I don't know if you guys can see it. So I can rewrite it as, so you see that b to the y, it looks like your b is here. B is 7, y is x, and x is 60. So I can rewrite it as what? Log base 7, right? Base 7 of what? Log base 7 of 60 equal x. You see that? You see, I kind of go backward. Okay. But when you apply the law principle, I mean, you must be able to see it clearly. You see that? What they give you is this. What they give you is a 7 to the x equals 60. You have to be able to recognize 60 in your case is x, and x is y. and 7 is B. Okay, so I can rewrite it as log base B, but B right now is your 7. Okay, so mean log base B of 60, X is your value right here, equal X. And that is your answer. Okay. So I think into some student, I mean, using the log principle to rewrite to get your final answer will be hard for you, because it's very hard for you to see which one is X, which one is B, which one is Y. Okay, so this is what I recommend. Okay, this is what I recommend. Even though that log principle is one of the method we use, but I recommend that every time you have different base, that you can convert it to each other, you can convert it to the same one. Then you just take log both sides. You just take log both sides. Okay, because even though you never learned log equation, but I mean, when you take log both sides, you can apply the log property. Okay, all right. So I recommend that every time you have the different base, you just take log both sides, and you can take log of any base you want. Over here, I take log base 11, take log base 9. You can also take natural log or log base 10 if you want. Okay, okay. I mean, because when you apply the log principle to go backward, it's kind of hard for you to see. Okay, so in this case, there's another way. Okay, so this is method 1. So there's another way, which is you take log both sides. So I'm gonna take log both sides. Okay, I'm gonna take log both. I'm gonna take log base 7 both sides. Okay, so this is what you get. This is give you log base 7 of 7, so that I can write the X in the front. Okay, log base 7 of 7 give you 1. So 1 times X is X equal log base 7 of 6. You see, the answer is the same. It is the same. Okay. Even though that the log principle is one of the method, but I mean, it's kind of tricky. I mean, for you to be able to see backward. So I recommend to take log both sides. Take log both sides, or we use equivalence property. Okay. Any question from me? Anything here you don't get it? All right. All right. So on Thursday, I'm gonna give you more example. Okay, so your job right now is to try to understand the example I'm giving you right now. Okay, watch the video, or let's watch the video first. Watch the video. Okay, try to understand example in the video. Okay, redo the problems. Redo the problem I give you today. Okay, then you can start your assignment. Okay, then on Thursday I give you more example on solving exponential equation. So we're gonna spend a whole week for this. Okay, but in order to master it, you have to memorize all the property. So everything all the formula I boxed them. You have to know. Okay. Any concept? Any other question? All right. So I'm just go ahead and take attendance really quick, and we can stop today. And when I'm taking attendance, you can come up with any question you want to. So today is April 6th. All right, I'm gonna just start calling the name. Okay, so look here. I can see him. Jasmine.
Here.
Lauren.
Here.
Emma.
Here.
Emery.
Here.
Continue with your homework, okay? Elisa.
Here.
Nadia.
Here.
Max.
Here.
Alberto.
Here.
Gabriel.
Here.
All right. Bye-bye. See you next time.